Sure, I'm not muted this time. Okay. All right, guys, let's get to work. We're moving on 1.7. This is material for test 3. Inequalities. It's a brand new pen here. Hold on a second. So instead of solving an equation, you're going to solve an inequality. All that means is there's a less than or greater than. That's all that means. All the steps are the same. Solving for x, everything is the same. There's one extra detail. Just one extra thing. Okay, so let's go ahead and do it. Let's do one that has that extra step. So solve the inequality. Linear, we're going to do linear first. Inequality. Negative 2x plus 7 greater than negative 5 or less than negative 5. So pretend it's an equals. It's not, but pretend. What would you do first to solve for x? Yeah, we need to isolate it. So what's the first operation you would do to both sides?
Subtraction of both sides.
Yeah, you would subtract 7, right? So then you'd end up here, negative 2x less than negative 5 minus 7 becomes more negative.
Times 12.
Yeah, 12. But negative 12. Okay. Now, what would be the next thing you do?
Divide negative 2 from negative 12. You get 5
Yeah.
to 6.
So you would divide both sides by negative 2. Now, this is where the new step happens. Whenever you divide or multiply by a negative on both sides, the inequality symbol will flip the other direction. But as you can see, everything else is the same, right? Same thing.
So when you have two negatives, it goes the opposite way.
So whenever you divide by negative or multiply by negative on both sides, it'll flip anytime. So right here, I'll make a note. When you multiply or divide both sides by a negative, flip the inequality symbol. All right, is that straightforward? But now you have to interpret the solution. What does this mean? We finished, but what does this mean? What is x? Forward. If it's pointing to the right. Yeah, so it's always pointing at the smaller one. So x is greater than 6. So that means anything above 6 is the solution. Okay. So before it was x equal to something specific, one answer. This time it's anything above 6. There's many answers.
So this would be 2 parentheses encased in the on the number line, right?
Yeah, it'll be an interval and yeah, you can graph it on a number line. So the solution set using this notation would be like this: x such that x is greater than 6. So this is called a set builder notation. And they use little braces like this. X, the first x is what variable they're talking about. That straight up bar right there is such that, and then whatever your x is doing. Okay, this is set builder notation. Interval notation would be start at 6 and go all the way to the right forever. This is interval notation. You put a bracket if you're including the 6, but this says greater than 6, not equal to 6. So you cannot put a bracket here. So visually, you would say a number line. Say we have a 0, 1, 2, 4. Right, all the way till forever. You would put a parentheses right here. And just say, just kind of shade this guy here, put an arrow going forever. Okay. Which is basically what this is. So this will mirror this. Anyway, is that clear? Do you see why it's this way? Okay, let's do another one. Another linear type. Let's see here. Slightly more complicated. You guys cool on number 1? So which part? Here or here? Okay, so right here, I'll make you a note here. This bar means such that this X right here is the one in question, whatever variable you're talking about is this one. And over here is whatever's happening. Like if they tell you know what, X is between 5 and 7, you would have that statement here. So this is like the statement. And this is the variable that we're talking about. So it's kind of like in programming when you define your variable and then say what you're going to do with it. Okay. So define the X such that it does this. Okay. I prefer this one, just straightforward. You can use whatever you want. I just want to make sure you understand what this is and visually what it looks like. Right? It looks like this. Any other questions on number 1? Which part? Oh, such that bar means such that straight line. One more details. Another example of fun. You want more details? It's what it is. Okay. All right. Number 2.
Which one's on the assignment we moved on?
Yeah, what's up, man?
This map statement, is that a 2 or an S or?
2.
Okay.
1. Whenever you see that, that's the saying X between 1 and 2. Or you can read it as 1 is less than X, which is less than 2, but that's weird. So when I read these statements, X is between these two values. So if it's like 1 and 10, say all the numbers between 1 and 10.
So if you were gonna put two specific numbers on. You would
Yeah.
put the less than or greater sign in between those two.
Yeah, let's say I have a 5. So on a number line, you have 1, 2, 3, 4, 5. Oops. 5. So everything in here would be a solution.
Would be a possible answer.
Yeah.
Okay.
But since they don't have equal to, you would not include the 1 and 5. Okay. Okay, let's do another one. Number 2. So again, everything's the same. So how would you solve for x? Just pretend this is an equals. It's all the rules are the same.
-2, -2x. And right side.
You want to do minus 2x on both sides? Okay. So we get 3 minus 6x greater than or equal to 8, correct?
Three.
Minus the 3. We get negative 6x greater than or equal to 5. What's the last thing you would do?
I think divide.
So this is where the new thing comes into play, right? We said when you divide by a negative, what happens?
The sign thing is flip.
Yeah, the inequality will flip the other direction. Any questions along the way? So first thing we did was subtract 2x, then subtract 3, divide by negative 6. Those are the operations we did. And you could have done it many different ways, but you will end up here no matter what. Now, how do we read this and what does this mean?
Is greater than or less than, greater than or equal to, negative 5/6.
Close, but
Less than.
yeah, so whenever you point at it always points at the smaller one, right? I think in elementary, they told us, they told me, I don't know about you guys, they said the smaller one eats the big one, right?
Oh, yeah, there you go.
Crocodile.
Crocodile eats the big one.
Okay.
But that was a long time ago, so I forgive you, forgot. So where's 5/6? Negative 5/6. That looks weird. And what is it as a decimal? Negative 5/6. You divide on your calculator, what would that be? No, it's almost 2, right? Or sorry, almost 1. Sorry.
Negative 0.888.
That's about somewhere around there, right? Somewhere around there. Now, the only difference you have equal to, you put a bracket. Everything below is a solution. So graphically, you would do this. I'm sure yours would be much prettier. Go from negative infinity, you always put the lowest one first for interval notation. Negative infinity until a biggest value, which is biggest one always goes first. Okay. Set builder would be x such that x is below or equal to negative 5/6. I don't know which one they're gonna use, but so I'm gonna show you both of them. In case you're reading a random math book and, when you're bored. You don't know both.
See, hombre, well, who's not,
That's what you guys do in your free time. I'm bored today. I'm gonna open up this math book. Okay. Any questions on number 2? It's not too bad, I hope.
so.
All right. Let's do a 3-part inequality, which will result in something like this on the board. You guys cool on number 2 before I turn the page? Can wait a bit if you want.
Can you go back up? Real quick? Yeah, I am.
Yeah, no worries.
Did you have another page? Chris?
What's up? Yeah, when you're graphing it, I mean, you can just put in your best estimate. If there's a grapher online, it should have a tolerance to be kind of close off by a certain percentage. Yeah. Any other questions? 1.7. This is the first section for exam 3. Which reminds me, I have opened for last chance for everybody. If you're behind, you can redo, you can still get exam 1 done and exam 2 done by the end of spring break. After that, I'm assuming you don't care, and I'm gonna just keep going.
Use the other word you use there.
I'm being recorded.
So on the test prep, even though we still get a maximum grade, we still gotta do the test correction.
And test corrections are optional. It's for your own benefit. If you feel like it's good enough, I will go in there. I still need to grade all of them, so I'm gonna grade this Thursday morning all the first attempts, and if you're happy with that, then that's fine. If you want to do your test corrections, or if you already did, then I'll grade those next. Okay, if you haven't done them, then you have the opportunity to the end of spring break. Same for exam 2. Yes. Those are not for a grade. Those are just to make sure you knew how everything was going to work. And
Yeah.
oh, okay, I'll check this out, but again, they're not for a grade. Those are just to make sure you were aware what you're gonna need. Okay. There's orientation. The only thing that affects your grade is exams affect them heavily, obviously, 50%. The other 50% are quizzes, discussions, homework. Homework is 20%. Okay, I still need to grade discussions. Haven't done so. I'm
Like to
slacking.
read through all those, right?
Yeah, I need to read through them. So I'm gonna do during spring break. Okay, number 3. Okay, so this is a 3-part inequality. So solve the 3-part inequality. See how there's 3 sides. So whatever you do to, I guess, focus on the center, because you're trying to solve for x and the x is in the middle. So move the x's to the middle, and whatever you do to one side, you do to all 3 sides. It's almost the same as the last question, just you have an extra side to account for.
But only see,
Yeah.
Okay, because you said focus on the X's.
I mean, you could have a question that has X's over here
Yeah.
and in here. So that could happen, so I want to make sure I mention it.
So. Just for, I guess, general purposes, 6x, let's say, for instance, it was, 6x minus 8x. You would go right into I guess, the subtraction of those two x's.
Well, you would combine them if they were the same. Like, there would be like terms in that case. But if there's an 8x over here, you would have to subtract it. But most likely it should be in the center.
Okay, because I have a question that I stumbled upon during this unit.
Hmm.
That it was, that it made me subtract the x's. And when I try to combine them, instead of my answer was wrong.
Yeah, we could check it out after we finish lecture.
After class.
Okay, so what would you guys do first? Focus on the center.
Add the 8.
Yeah, do +8 everywhere. Add 8 to all sides. So you get 7, last center equal to 6x, last center equal to 12. Do you agree with my addition? Okay. What would you do next?
Wouldn't that be a 9?
Is it? Yeah, you're right. Do you agree, dude? It's too late. Just kidding.
No, it's not that. I know that's my kid.
That's why I asked, because I can't add numbers. Okay. What do we do next? Yeah, we're isolating that x, right? So we gotta divide the 6. Because if we subtract the 9, then we'd bring it back to the middle. Well, whatever we do, we have to do to all 3 sides, so it would appear in the middle if we did that. You see what I mean? Yeah, so yeah, focus on the center, focus on getting the x by itself right in the middle. That's the goal. But whatever operation you choose to do, you gotta do to all 3 sides. Okay, so right, someone said add 8, so we did +8 +8 +8. We got to here, now we're gonna divide by 6 everywhere. So now we are here.
But you get a decimal for the first one.
Yeah, it's gonna be a fraction. That's true. Decimal. 9/6. What is that reduced?
36, 3/2.
Yeah. Okay, so divide by 6 on all 3 sides. Okay, so set builder. Your braces x such that x is between 3/2 and 2. So this time we are including them. So how would you write it as an interval?
Essentially, something number line. And it would be,
You want to do the graph first?
yeah, I guess the graph is cool.
So 3/2 is about here, right? 2 is over here.
I think that's infinity, right?
Was telling you it's between these 2 numbers,
You're not going past 2.
right? You agree with the picture?
You can cut. I concur with the picture.
So if we're between 3/2 and 2,
3 has positive or negative. Yeah.
Oh, yeah, you're right. Telling you, can't count. It's right there.
You're a math teacher? Oh, you already have.
Well, I don't teach addition. Okay. What's after 3/2 is right here. You agree with that? I asked you before and you agreed, so. Sure. 3/2 is 1.5, right? So it should be after 1. So we're including them, you put your brackets. So really, we're just right here. So we would say bracket 3/2, comma 2, bracket. So make sure you put your brackets on your values because they are equal to. Never put bracket on infinity. That's an easy rule to remember. Always parentheses, because it's not a value. Okay,
It's really a concept and not actual number,
yeah,
as we discussed last time.
this is true. It's not a number. All right, any other questions on 3? So when you read this, this is saying everything between 3/2 and 2, including the endpoints, so the brackets tell you. So it's different from a coordinate. But they look the same though, so be careful. So if they tell us, if they tell you it's an interval, like for example, they say this interval, I mean everything between 1 and 5, but not including the endpoints. That would be 1, 5, everything in here. But if they tell you the point, that would be a location, right? But they look the same. So
So they would have to specifically outright say interval or point.
yeah, you need the context. Yeah, they have to tell you. Otherwise, like, what the hell is it? Right?
Could you go on all day about what that could represent? In theory. Because if you would erase interval, I would think of it would be a point. But also if I flip it on the other side, it'd be like, well, it could be 2 positions between that point and this point.
Yeah, so they have to tell you, otherwise you don't know. But if I don't see, I would make assumptions, but I mean, might be wrong though.
What would be the third assumption on that?
Third. I don't know, there's a lot of notation for that. You could use it for, I mean, I've seen it used for dice throws. Like throwing a dice,
Oh, 1 in 5,
Yeah.
or how many times would you get 6 or
stuff like
Well-
that. Yeah, like this would be an outcome of 1 in 5 or whatever. So it really depends, man. All right, you guys cool on 3 then? All right, let's do something a bit more difficult then. Solving a quadratic inequality. So these are a little more annoying, I guess.
Remember that.
All right. So let's solve the quadratic. It's gonna be very similar to the equation type. You gotta do factoring. When you factor though, it changes.
Say it one more time. Yeah.
And damage agent. All right, so the procedure is the same as when you have an equation, okay?
Okay.
You got a factor, but the part after that is when it changes and it becomes more difficult. You can't just say x equals this, but you'll see. How would you factor this first? Because that's the first step.
These get pretty confusing once they get bigger numbers, correct? And like more more variables within the equations.
Well, I mean, it depends on what factoring technique you gotta use. So maybe the factoring is harder than the other ones. It'd be a basic factoring, could be a harder one. Depends. But I gave you like many different ways to factor.
Yeah,
So all those are still in play here.
because I ran into a question specifically on the homework. I don't remember which one it was. But I remember it gave me so much trouble and it looked like this.
Mhm.
It's just, it was a much, they had more variables and it was much bigger.
Yeah,
And
well,
number was wise also too.
yeah, that can make it more challenging.
And I was just like.
But let's start with an easy one first, though. It's the first one.
Is this kind of like grouping or no?
No, just the basic trial and error. How does it factor? What do you guys think? Right, if you look at that negative 15, factors of negative 15 that add up to -2.
3 and 5.
Which one's negative? Which one's positive?
-3.
No. You add them together, this would be -2, right?
Oh, yeah, because if you look at it in a money sense, if you have -$5, you put $3, it's still -$2.
Hmm.
Right?
Yeah. Yeah. Oops. Okay. So we chose this one because it gives me a -2. Okay. So this is where it changes. Usually we go straight to here and say, all right, well. X minus 5 equals 0. X plus 3 equals 0. X equals 5. X equals -3. But because it's an inequality, you have to create a number line and test around it to see, is it less than 0 in between, after, before. Okay, so this is where it changes. But you see how this is the same up until this point, right? So this is where it changes right here. So separate your number line. So I want to know, are we positive after 5, between -3 and 5, and below -3? So choose values that you can test. Choose easy numbers. You're going to plug it in here. And if it's less than or equal to 0, then that's part of the solution set. If it's not less than or equal to 0, then you don't include it. Okay. So what's an easy number above 5? Yeah, let's do 6. So test x equals 6. So that'll be 6 squared minus 2 times 6 minus 15. Is that less than or equal to 0? That's the question. Okay. So PEMDAS stuff, right? At this point, this is 36 minus 12 minus 15. Is that less than or equal to 0? Looks like 9, right? Is this less than or equal to 0? No. False statement. So we're not gonna conclude anything above 5. What's an easy number between -3 and 5?
3, regular 3. Positive.
What's the easiest one?
2.
0. Close, that's close. 2 away. Yeah, always use 0 when you can, because it's, less work. Math's all about finding ways to work less. 0. 0. These will be gone. Is -15 less than or equal to 0? Okay, so cool. So all the solutions between -3 and -5. Well, all the numbers will be solutions. Okay, part of the set. All right, now check below -3. Right down here, what do you think below -3? So below -3. -4. Okay. Now you can choose anything you want as long as it's below and above these values. But once you find out that one works in here, then you're good. Everything else inside will work. Okay, -4 squared, what is that? -16, -2 times -4. Be positive or negative? Okay. 16 minus 5 is 1 plus 8 is 9. False statement. So I can't use anything below here. So what is the solution set? Yeah, it would be everything from -3 until 5, right? With brackets. Using the other notation, this would be x such that x is between -3 and 5. So x is you got to put that equal to part. Now, of course, the visual would be -3 with a bracket to 5. Any questions on any of the steps? So anytime you have a quadratic, you have to test around those values that you solve for.
I guess I have a question.
What's up, man?
My question is, I understand how we got the broken down version of the quadratic.
Mhm.
Why is it that we wrote down x minus 5 equals 0 and then? I know they're the representation of what you see above the second line of the quadratic.
Mhm.
Why is it that we were, I guess, testing these other numbers when we already know that you can only go between -3 and 5.
Cause it could have happened. It could have been possible that something worked out here, so you would have included everything after 5 as well. So you had to check.
So let's just say miraculously, the 6 worked.
Mhm.
So we would include that and add all the other numbers to infinity?
Yeah.
Or it's just like, it could just be that one specific one.
That'd be everything after.
What about like we just tested -4? That was a false statement, correct?
Mm-hmm.
Why is it that we test, so nothing after -3 is a plausible thing either?
Yeah, nothing below, because this was false. Now, if it was true, you would include all the way to negative.
Negative infinity, correct?
Yeah.
Okay.
And the reason, if you're wondering like well, how you can guarantee that there won't be another number that'll suddenly work or change it, is because of the zeros. Because the functions will not change after the 0 unless there's another 0 to come back down. See what I mean?
So could it have worked positive?
No, like for example, this is a quadratic, right? And then we had 2 zeros and what was it again? -3.
3.
Let's pretend this is -3 and this is 5. You see that there's no reason to test. We test one of them, right? We test this guy, but there's no reason to test again because it's not going to come back down because it's the quadratic. So if it was a cubic, then yeah, it could come back down, but that would mean there's another 0. But since we have 2 zeros, it's quadratic, we know for a fact it's no matter what you test, once we know that it's positive or negative, it's not going to change.
So would it be safe to say that that's 2 numbers after 5?
You could test if you want, but it won't make a difference.
And same goes with
I could test like 10,000 out here and it's still gonna be false.
Well, you can go that actually, but okay.
See what I mean?
They're just from Romans and all.
Yeah, because this graph is still pointing up. The y values will keep being positive.
Well, what? So for us to come back down this way, it would have to be a 0, right?
Yeah, there would have to be another 0, like. The function, it'd have to be a different function. And it would have to come down like this. So then you would test between these zeros and then after that. See what I mean?
All right. And this section, will we be running into that or no?
I think those ideas, I think later in the class.
I just want to kind of have next one. Thanks.
Yeah, it'll come up later. Okay. Let's do one more of these and we'll move on to something else. You guys cool on example 4? Okay.
Yeah, you're intrigued on that.
Oh, I know, right.
The geometry?
Yeah, I always test between zeros and after zeros. So if you only had 1 0, you would just test after before.
Listen, there you go, let it out, bro. It's your
All right.
body telling you there's something in your nose that's not supposed to be there.
Okay, so AC method.
Oh.
So A times C is negative 12, right?
We shorter.
You eat before you come.
Yeah, I eat all my food. I bring my food.
No, they're eating your food.
Huh?
They're eating your food.
I ate all my food. I have my food right.
Oh.
Well, I can kind of combat your theory on it before you get the plans.
Before we go?
Oh, which one?
I said, I think I got a pretty good answer for your, even before you get the plan. I think you'd be okay with eating than sleeping.
True.
No.
Oh, no, okay. Thank you. All right, let's get to work.
All right.
You ready, Kimberly? Crystal?
A little bit. I don't know, I've been looking at this for 5 hours. So like.
Okay, let's get to work. Well, I'm gonna call security. Just kidding. All right.
Waiting for you to start.
Factors of negative 12 add up to negative 11.
Isn't it 11? What do you have the 12 up there?
We need the factors of negative 12 that add up to 11.
Okay.
Okay. Negative 3 plus 4, negative 11, positive 11. We want this guy. So AC method says you got to force it into a grouping question, right? Okay, so I broke up the center term into negative 12 plus x, which are these same numbers right here. Same numbers. That's the AC method, which I'm hoping you already went over. But if not, this is it right here. So factor, what do these two have in common? First two terms, what do they have in common? X and what else? So factor 3x from the first two terms. What do you have left when you factor them? Yeah, x minus 4. Do these have anything in common? What do you think, Crystal? You see anything? Just the 1, right? So we can factor a 1. If you see nothing, just put a plus 1. Okay. So at this point, we're almost done. Just factor that the new GCF there from the entire thing. They both have x minus 4. That's it. The next step is setting each part to 0, and then we're going to test around all of the zeros. Okay. X minus 4 equals 0. 3x plus 1 equals 0. X is 4. X here will be negative 1/3. Let's skip the solving part. Let's get to the new stuff. Any questions on the factorization step? Is that okay? Yeah.
Yes, for 3x plus 1, what does that turn into? Negative 1/3?
Yes.
What is negative?
Oh, why? That's it does. The step I didn't show was this. Subtract the 1. Divided by 3. Right?
Which one's on this quotient?
Yeah.
What did the X equal -4?
When you do +4.
So you do +4. What would you do +4 then, if it's a representation of negative? Gotcha. Right, thanks.
Okay. So now we test. Okay. So let's test after 4. What's a good number? Yeah, guess let's do 5. So we're gonna get 3 times 5 squared minus 11 times 5 minus 4. Is that greater than 0? That's the question. And if it is, then we include everything after 4. Although, do we include 4? Why not?
It's not equal. It doesn't have a -1 for that. It implies that it's equal to or greater than.
Yeah, because if you plug in 4, it's equal to 0, right? Plug in 4 right there. So we saw when this is 0, it wants it above 0, so then I cannot include this guy here. There's holes at these locations. But we do need to know, what about after, what about before? That still needs to be tested. So after 4, we get what? 3 times 25 minus 55 minus 4. That will be what? 16? No?
Yeah, 16.
Yeah, that's right. Okay, so it's true, correct? So everything after 4 is fine. Just not at 4. Test in between. What would you choose? What's the easiest?
0.
Yeah, let's do 0. 0 is between -1/3 and 4. So is 3 times 0 squared minus 11 times 0 minus 4 greater than 0? No, right? This is false. You guys cool so far? All right.
So. How would you put, since you have a hole in 4 and -1/3, how would you include that in your notation?
It depends. For sure, we're gonna have x greater than 4. But I don't know. Depends what happens over here. But this was also false, then the answer would be x greater than 4.
And then we wouldn't include those numbers, correct?
Yeah, nothing else included. But we gotta test below -1/3 first. What's a good number?
-1.
Yeah, that's a good one. So 3 times -1 squared minus 11 times -1 minus 4, is that greater than 0? Yeah. This will be 3 times 1 plus 11 minus 4. That 10? Okay. So we're cool below -1/3 and above 4. So solution set is gonna be negative infinity all the way until -1/3, but do not include the third. Then you have to do union, combine it with the other part, everything above 4.
Why wouldn't you put brackets on the -1/3 and then positive 4?
That's what I was saying earlier. What happens if you plug in 4 here?
0 out.
But it says it needs to be above 0. So you can't. That's why they have holes here.
Okay.
Yeah, that makes sense to everyone. Is that okay? Is it weird? It's all gonna depend on the factoring, right? So you factor it and then you test. If you're still struggling with factoring, then this will be harder than it needs to be. Okay. Well, that's all for 1/7, I think. You know what? There's one last thing. This weird fraction thing. Okay. Let's do this gross problem here. Yes. It should if it wants interval notation. There should be a button in there or a symbol. Oh, no, I'm okay. Thank you. I already ate too much.
I was gonna eat them for the end of the class. That's when I get sleepy. Number 6 is super long one. Plus, I can put a fresh page, that's why.
I would say yes. I wouldn't take a chance.
Yeah, because a lot of it's like kind of like taking up a lot of the page.
All right, so 3x plus 1 over 2x minus 3 less than 4. So we gotta deal with this their rational expression. the algebraic fraction. Okay. So try to set them to 0 as well, like before. You're just gonna have to deal with this 4. So if I subtract both sides by 4, you agree we would end up here. Is that okay? Now, how do you subtract these fractions? Yeah, we need this common denominator. What is the LCD? No, what was that rule I showed you at the beginning of the semester, right? Remember I told you to it's gonna be necessary soon. Look at all the denominators. You have one denominator.
They often go into 12.
You take the whole thing, that's the whole thing on the bottom. And the other one technically has a 1 underneath, correct? Does this factor? Since they're both prime, the rule says what?
Unfactorable.
Right, if you were doing. If you're doing this. These are prime. What would the LCD be? Yeah, when they're prime, you just multiply them together, so. LCD here is just 2x minus 3. So it gets harder if. If they're not prime. Then you have to factor. Find out what that new LCD is gonna be.
So. let's see.
So this one's not too bad. What's up?
You wouldn't be able to get a common denominator to that.
No, you can. It's gonna be that. So right here, multiply by this.
That would go on the bottom, right?
I mean, it technically could, but we don't want to do that. So distribute the 4. In the next step, I guess. See how now I can subtract them, right? But let me distribute in an extra step. This will be 8x minus 12. Subtract these fractions and you're going to get minus this whole thing. Oops. Okay, I'm adding extra steps just because I know this is a little weird. Finally, you'll end up with negative 5x on top. Plus 13. So this where it's a little different from the quadratic at this point. Any questions on subtracting fractions? Is it okay?
You skipped the step, didn't you?
Which step?
But I mean, like, you didn't write the step down. I know you did in your head
Which one?
when it comes to from the second to the last one.
From here to here?
Yeah,
Yeah, here you combine the like terms.
okay. So it would be negative 5x.
Yeah, -8 plus 3 is this, 1 plus 12 is 13.
Why couldn't you move that 3 over to the end? Up to the 8 side?
Which 3? This one?
Yeah, that 3. Why couldn't you combine it to the other side?
I combined these two.
Yeah, that's what I'm saying.
Yeah, that's this. See it?
Okay, so either way you cut it, it still gives you that, okay.
Yeah, it doesn't matter if they're not right next to each other or not, but they do combine. Yes.
Would you still go about kind of testing on the ground for them? Or not?
We still- Yeah, we still gotta do test points, but the values we're gonna test around are gonna be the ones that make the denominator 0. So that's where it changes. I'm gonna make a note right here. Test around the X values that make the numerator and denominator 0. So test around the values that make the numerator and denominator 0. So set the top to 0, set the bottom to 0, find out what that value is, then test in between, after, etc. Okay. Does that make sense? We'll do that in the next page. One more time, sorry.
I did lots of fun.
Oh, we're gonna do the next step on the next page.
Oh, I don't like you still.
No, just, there was a lot, we did a lot in algebra steps, so I wanted to slow down a bit. Are you guys cool on the algebra? Are there any steps here that bothered you? No? You guys are all pros, yeah?
I would ask, for the perspective of that, we'll do another example, one going to the denominator value, do you think it's a living part?
Yeah, we can, we can.
Somewhat so it's in format. So think better for what you're around.
Yes. Let me see if it pops up here or not. I think we will later on. You don't have to worry about that here yet. I think it's in the later section. You guys are all cool. Okay then. So set numerator, oops, to 0. Numerator was -5x plus 13, right? X will be something. So solve for X, set the numerator equal to 0. Subtract 13, divide by -5, you get to here, positive 13/5. And then set the denominator to 0.
We're still on the same problem.
Yep.
So they.
Yeah. Solve for X, we get to here. So these are numbers you're gonna test around. So I saved the best for last, for this section. Which one's bigger, 13/5 or 3/2?
3/2.
What was your question?
13/5 bigger or 3/2 bigger? Yeah, 13/5.
Oh, yeah.
Oh, 3/2.
Punch it in your calculator.
Yeah.
What's the decimal?
That's because of the variables like by itself, it's like, if something's larger than 2, or it's because of quantity from it. We said 13.
Yeah, 13/5 I believe would be bigger. Because
It
it's
is bigger.
several times bigger than 1, right? Because every time you have a 5,
Oh, yeah.
it's 1, another 5 is 2, it's almost 3.
You have it.
It's 13/5 is like what, 13, sorry, 2.6 or something, 2.7,
Exactly, 2.6.
okay,
2.2.
so 3/2 is 1.5, right? Okay, so yeah, this one's bigger. Just think about how many holes are in there, how many whole numbers. There's no like general idea, but anyway. They were both positive, correct? Yes. I'll put the decimal just so you can see it better. What do we test above 13/5? Yeah, I mean, you could choose all kinds of stuff, right? As long as it's bigger than 2.6, we're good. So I think 3 would be the easiest one though. For up here. So we will have into the original statement is 3 times 3 plus 1 over 2 times 3 minus 1 or minus 3, sorry. Is that less than 4? It'd be 9 plus 1 right up top. 6 minus 3. Is that less than 4?
Oh, yeah.
10/3, what is that? Like 3 point. Yeah,
301/3.
so we're good. We're good. Okay, what's an easy number between 1.5 and 2.6?
2.
Yeah, I think 2 would be the best, right? Otherwise, we'd have to use decimals or fractions. And I don't want to do that. Yeah, it's cool so far.
So,
You see it? What's bugging you, Rigo? Yeah, so every 3 you have a hole, so it'd be 3 holes, an extra third. Three thirds would be 1, 6/3 would be 2, 9/3 would be 3.
Oh, you really want to, okay. I think it's like.
Something or a bit.
Oh, no, yeah, we're choosing something between here. We picked 2. I'm sorry, we picked 3 up here. That's right. And we ended up with something below 4, so everything up here is fine. everything up here.
These are the month that one, we have the-
Is this less than 4?
6, 7, 6, that's 3.
Seven over
Yeah.
one. It was seven. It was seven.
Yeah, for sure.
So 7 is less than 4?
It's bigger,
Yeah.
greater than,
So is it false or true?
that's false.
So that means we're not worried about stuff in here. What's the easy number below 1.5? The easiest. One would be cool, but I like 0 better. You can choose whatever you want. It'll still work out as long as it's below those values. Okay,
So it's just.
is this less than 4? Is negative 1/3 less than 4? Any questions on the test part,
What?
the testing?
Oh, just- I found a way. What?
Yeah, so we're cool down here. So what is the solution set? Finally done.
I know, right? Yeah.
5 and 6.
Yeah, everything below 1.5, right? So as an interval, we gotta go to negative, the bottom part is negative infinity, right? So 3/2, which is 1.5. Union,
6.
remember, they're not gonna take decimals, so. But I know what you mean. But just, decimals kind of helps you see a little bit, so feel free to use them. Just make sure you punch these in.
Did it tell you which format and when say what's it?
It should, yeah. They want it in this format. This one, this particular example. I don't know. Check. Well, I can check if you like. I haven't checked myself. The book is doing it this way. All right, let's take a 10-minute break.
You're on.
We did a lot of math right now. We'll stretch your legs and we'll do some more in a second. Sorry for the. I appreciate you though. Okay, so given this function, quadratic function. I'm gonna go ahead and graph it for you. It has a 0 at 1 and 5. It has a vertex at 3, -4. Okay. So this right here, this point is 3 comma -4. This valley, the lowest point, is called the vertex. Let me see the number here. One moment. I need to find the name for this. Yeah, they do call it that. Part A, find the domain.
Oh, is this still at A3?
Yeah, A through E. 3.1.
The points for that are 1, 1 and 5, right? And then the vertex. Is that correct?
Well, it
It's
keeps-
axis, if they call it,
It
right?
keeps going forever.
Isn't it called an axis?
Yeah, the axis rotation would be the next part.
Vertex and axis.
Mhm. Yeah, so first is the domain. What is a domain? Right. All the x values that are possible for this function is the domain, all the inputs. So there is nothing you can't plug in. It'll keep going to the right forever, eventually covering all your x values. To the left forever, eventually covering all your x values. This looks a little stiff here to me. Curve that for you there. Okay. Find a domain. It's going to be every single x value. It's everything that you can plug in. Okay. If you see no issues, you see nothing that you can't plug in, like no restrictions, then you should just assume everything is fine, or you can graph it and see it, that it'll keep going and cover all your x values. But does it cover all the y values?
No.
What's the lowest y value?
Oh, 1, 0.
One of the things is find the one,
Range.
range.
So range is referring to what is the lowest y and the highest y.
Right.
So the lowest y is right there, right? At the vertex.
Yes.
Yeah, it's gonna be -4. So -4 is the lowest point. What is the highest point?
3.
Well, it keeps going up, doesn't it?
Infinity.
Yeah, it shoots off forever.
And they're gonna get it quickly and say, but it's fine.
I had to correct myself.
-4 to infinity. Axis of rotation.
Oh, Mr. Gonzalez,
Mhm.
The homework, when it pertains to like the little like brackets and the parentheses. It's super sensitive, isn't it? Because like. I had the same exact answer as the -4 to infinity. But I had it flip-flop and it said it was wrong.
Yeah, it has to be exact.
It has to be exact.
Yeah, because the lowest one is always first.
Okay.
Infinity is the largest, so it's always gonna be on the right. You can't flip flop it.
Okay.
Infinity is always gonna be on the right.
Yeah.
Even if it's negative. infinity.
Negative infinity would be on the left. That will always be on the left. So axis of rotation is gonna be the x value of your vertex. Okay. Now the intercepts, part D, says find the y-intercept. Do you remember how to find y-intercept? Yeah, they'll probably give you a graph, but if they don't, do you know how to find it?
You said, say that again, I'm sorry.
How do you find the y-intercept?
Let X be 0.
Yeah, let X be 0. So in other words, plug in 0 for all your X's. So that'll be -3 squared minus 4, which is, what is that? 5?
Think so.
So the intercept is 0, 5. Any questions so far? Part D. So in order to find y-intercept, you let the X be 0. So this is the function they gave you. Plug in 0 for any X, it's right there. So once you do that, you get 0 minus 3 squared, which is -3 squared. -3 squared is 9. 9 minus 4 is 5. So when X is 0, Y is 5. That makes sense? How do you find the x-intercepts?
Let Y be 0.
And in this case, what is Y?
Y is should
-4.
the F.
Yeah, the F. So X minus 3, set this function equal to 0. Solve for X. How would you solve for X here?
Hold on, right, that's not.
We did that last week, I think on Tuesday. Did something like this.
Oh, you gotta isolate X, so you would have to do the parentheses first.
Oh, you want to expand it? You could expand it and see if it factors. But since this is a square, right? You could move the 4 over here and square root both sides. That would be the shortest route. But you could expand this, combine it, see what happens. But use the square root property that we talked about last time to make your life a little easier.
Could you repeat that one more time?
Square root property. So square root both sides. Because this has a square on it. And the 4 is a square. So that should be a red flag telling you.
Because
Square root.
square root property on those squares, correct?
Yeah. The square root both sides, that'll cancel the square. But it'll tack on plus or minus on this side. So now we have X minus 3 equal to plus or minus 2. So what are the two X values?
This would be
Yeah, 5 is one of them. The other one? Negative. No,
It'd be positive 2.
plus 3, plus 3.
Sorry.
So those are the X values. With those are the X intercepts. So as points, you would write 5, 0 and 1, 0.
Those are the points, right?
Yeah, those are the points, which I had already given to you, right? They're right there. This is how you find them. You solve the quadratic equal to 0 to get intercepts. The solving part, you can be done many different ways because I just gave you like 6 different methods for solving a quadratic. So it all depends what kind of problem you got. This one just so happened, square root property was best. Anyway, any questions on this?
For the, when you're squaring, that's only if both numbers are able to be squared, right? So do you have a 3 and the 4? So they're squared, square rooted properly.
Are you asking why I chose it? The square root?
Oh, no, you can use it anytime that there is a square root property that.
Yeah, you can use it anytime you see like a square on something like this. That's the best time to use it. Especially if you can isolate to one term on the right side and left side. You don't want to use it when you have x squared plus x equal to 4, right? You don't want to do it there. Because this quantity is not squared. So you can't do it. Here you would try like trial and error or something, or quadratic formula, depending if it's factorable. Yeah. Okay. The last question, part F, I guess. What is the minimum value of this function?
Wouldn't that be the vertex?
Yeah. So if they ask for minimum or maximum, it's always going to be vertex. Okay.
How does that mean?
Did some homework.
No, because the only thing I was actually good in high school when it came to the math stuff was the quadratics, and the charting and graphing and the points and all that.
That's good. So you remember that part?
Because it's all right there for you. They pretty much give it to you. Just gotta write it down. Shit.
True. Yeah, if you can graph it, you have all the information. If you don't have a graph, then you gotta do some work. Okay,
That would be F, right? You said?
Yeah.
F would represent. Minimum, you said minimum?
Mhm. Out of space, so I'm gonna turn the page in a moment. Do you have any questions on number 1? So when it's in this form, see how it's kind of like square minus a number? I believe it's called standard form. When it's in standard form, you can peel off the vertex right away. You see how it's going to be the opposite to this number, 3. And then whatever this number here is, -4. So if it's in this form, you should know the vertex. I'm going to give you a formula on the next page.
Possible that like you have a probably multiple parameters and have to use that for put it into the minimum or maximum. Have two different vertexes.
Like if you had, like, what would they be asking? Like finding 2 separate ones or?
Yes, I think if that's for one, but there's like two vertexes, like the same. Graph, or would that not be possible?
Not for quadratics. It's not possible. Higher power functions, yes. So you can have functions that do something like this. weirdo stuff like that, so you can have peaks and valleys. But that would not be a quadratic, it'd be like a 7 power or something.
And so, yeah, it would have to be necessary to-
We do have techniques, I don't know if we might time on this plan, I forget. There are techniques to find zeros for high powered functions. To find these peaks and valleys for these. I think we need calculus. I don't know if there's a way around it.
We don't need that. We don't need that. We can barely do this.
Well, if you wanted to know that question, you need calculus. All right. Yes, cool, number 1. Number 2, oh, let me get that formula first, because it'll be helpful. Standard form of a quadratic. So if your function is equal to a times x minus h squared plus k, the first thing that you'll know is the vertex is at h comma k. Okay, so whatever sign's right there, just switch it to opposite only for the h. So if that's a -2, then it's 2 here. If it's a +2, then it's a -2. Make sense? It's opposite. Number 2. If that little a is positive,
Is that okay?
yes,
Okay.
HK. So if little a is positive, then you have a max. I'll put it down here. You have a maximum at HK. Hold up. Sorry, minimum. Alive. If A is negative, then you have a maximum. At HK. Domain will always be negative infinity to infinity. Range will always be k to infinity. If A is positive, negative infinity to k if A is negative.
Right.
Bracket on k only. You never put a bracket on infinity. Range. range. All right, I'll write it better. I think that's it. Let me see. I think this was. Y-intercept would be 0K. Again, it has to be in that form though. Axis of symmetry. Is X equal to H?
What about the x-intercept?
You gotta solve for it.
So wouldn't that be step 7 first, or no?
There's no easy way to get them. This is just like. You know, all the information by just looking at the equation is 1 through 7.
Okay.
Let's see here. One more formula here, or idea. Given a function equal to ax squared plus bx plus c. So let's say it's not in that special factored form as it like this. If it's not in this form, that means you can't just read off the vertex. Can't. So you could complete the square, or you can use this formula.
This is a different set of formulas.
This is a formula for the vertex if it's not in standard form. This is general form here. So right here, this top part is called standard form, right? That we wrote at the top. This one down here is general form. So the H will equal to negative B over 2A. K will equal to the function at negative B over 2A. This is the easiest way to get your vertex, because the other way is much harder. Completing the square is a little more difficult. But I'm gonna show you how to do it anyway in case they ask you to complete the square. But if they don't ask, use this. We'll do the next example in just a moment. The next example will be in general form, meaning you can't use any of this stuff from 1 through 7. So I'm going to give you one of each type. The last example was standard. This one, next one will not be. You could put it into standard form if you want to, but that requires work. But if it is, you see how you have all this information, right? So it might be worth it. It's up to you. Yes. Yeah. It's the whole thing is negative B over 2A. Maybe it's better if I put it up here in front. Because if the B is already negative, it would become a double negative. And to get K, whatever, you just plug in whatever this is into the function. That's it. You guys cool on this page? All right. Start the example in a second.
So to get K, you need to know what negative B over 2A is.
Yeah, you just divide that out and then find the number or fraction, plug it in here. Into this guy. Almost everything else would be the same. I mean, general and center are both quadratic, so all these properties apply. But you can't use a lot of this information. The domain will be the same. The range will be the same. It's just that finding that K and finding the H will be different. That's the only difference. So once you have this, you can answer pretty much all these questions up here.
Could you get liner tip for sure?
Y will still apply.
You still have to find K, right?
If you find H and K using this, let's say you have a general form, right? You find H and K, then that means you can know that you'll know this, right? And you'll know this. You can use these two as well as that and this. So you can use everything if you find these two. So that's one way to go about it. The other way would be to change this into standard form, which is harder.
So these two are two separate. Two separate formulas?
What do you mean? These two?
Yes, those two are their own separate formula.
Yeah, these will help you find H and K given this type of form.
Okay, so if it's given to us in general form, which is
Mhm.
exactly like that with the numbers filled in.
Yeah.
We can find the H and K using these two separate formulas.
Right.
Okay.
Right, and if it's in a standard, then you can look at, you can see the H and K,
Okay.
right? Like if you go back. Right, it was in standard, so we knew that it should be 3 and -4. Right? Okay. Example 2, I think it might be our last example for today. Sadly. Don't go. Given x squared minus 12x plus 35. Miss you guys. Okay. So we can use that formula to cheat our way to all that other information. Or you could complete the square. So I'm going to show you how to complete the square because there might be a question somewhere that says, do this. You have no choice, so let's go ahead and do it. So when you complete a square,
Guys. What are you doing right? This.
complete the square to get standard form. So what you do, it's gonna leave a little blank spot between the number and the x term. And then subtract whatever that blank is gonna be. So you gotta add a special number and then subtract it because we can't add it to both sides. It's just you have to add it and then undo it. So essentially I'm doing nothing. Right? Like for example, if the magical number was 2, you'd say +2 - 2. But I'm not going to combine them. It'll create a perfect square here, factor it, and then I'll just just combine these two numbers, whatever they are. So to find this number right here and here is going to be b squared. Sorry, b over 2 squared. That's what goes in those boxes. Or that line, I guess. So in our case, what is b?
B would be X, 12x.
Yeah, so that number, right, on the X. What is half of B squared?
Half of B squared is it's 6. Right, 6, yeah,
6 squared,
6 squared. So you still get 36.
36. So the magical number is 36. So once you add that number, the square will be complete. So plus 36 minus 36. That makes sense. That's how you complete the square. So I'm trying to add a number. I'm kind of disregarding that 35. I'm just kind of moving it aside and say, all right, how do I complete the square? What is it? What is a complete square? This would be a perfect square. When you FOIL it out. To see how this number makes this a perfect square. So if I did not have a 4 there. Let's say I had something weird. 7. So I need a 4, but I have a 7. So the question becomes, well, how do what is that number that I need? Let's pretend I didn't know it was a 4. What you would do. To leave a space, move that 7 over and then subtract whatever number that's gonna be. Half of 4 is 2, right? 2 squared. Is 4. So we already knew the answer. So you add that special number to complete it. So now this will factor into this piece here. So that's what we're trying to do. We're trying to add a number to this part here. In order to factor it into x plus something squared.
X squared and negative.
Yeah, so I'm just like, I'm gonna move that 30 because I know 35 is not giving me a perfect square. But that's essentially what I'm doing. Move it over here and say, all right, what is the number that will make this a perfect square? You find the number, make it. Take the b, divided by 2, then you square it. This is -6 squared 36. So now this right here, these 3 terms will be a perfect square. Okay. So they become. This becomes, let me add an extra step right there. So then you get x minus 6 squared. 35 minus 36. It's a 1, right? Yeah. So now we have it in standard form. Just like before, like the last question. Does that make sense?
Yeah.
So that's the goal. You're just trying to find a number that'll help you complete it. And we just kind of ignore that, whatever number it comes with. As if it was, so if it was already a square, then you don't have to do anything. But since it's not, we found the number that forced it into a square.
My
Yeah.
question is, you got the f of x equals. Open parentheses, x minus 6, close parentheses, squared minus 1. That would be the broken down version of x squared minus 12. Is that correct? Is that safe to assume?
One more time, sorry. This,
Yeah, do those correlate or do they? It's like the broken down form of that. X
Yeah,
squared
these-
minus 12.
yeah, let me add an extra step so you can see.
Sorry, I just.
No, yeah, I skipped a step. You're right.
Plus 1.
Okay, so this right here is gonna turn into x minus 6 when you factor it.
Okay.
So the idea is you turn it into a perfect square, meaning it factors into this. Okay.
Okay. I see it now. Whether that was my question, like that piece, is a factored form of that. Okay, I just wanted to make sure.
It's a good question.
Safe assume, that.
All right, we have 1 minute left. Does this make sense?
Pretty-
Okay.
Pretty good.
Well, can you not erase?
Okay. So anyway, the actual question is gonna ask you, what is a vertex? What is the intercept? What is the axis symmetry? All the same questions before. But when it's in this form, you can use all that information. Or you could find the vertex first and then answer all those questions. Okay. So there's two ways. This is the hard way. The easy way is using that formula. But you should know both. All right, you guys. If you have any questions, feel free to stay after. If not, I'll see you Thursday. We're gonna do 3 sections next time. Yeah.
Oh, you said that's, and so it's last test from all.
Yeah, test 2 is due after spring break. Test 3. I'm gonna move it to the week after spring break, but it's open now until then.
And 2 weeks still do. Before the results. Is something
Next Sunday.
next up?
Yeah, you can, if you wanna wait till spring break, you can. It's up to you.
Oh.
I gave you 1 extra week, but that's your fault. Yes. Yeah, anything I sent you is fine.
So. all 4 of these.
Yeah, that's okay. Okay, you also, if you want to write by hand formula pages or any formulas that you think you need, you can add those. Okay.
Right next.
Okay.
What's up, man?